Okay, hi everybody. We are learning today the redox reactions. Redox means reduction, and ox is oxidation. Reduction and oxidation. Now, reduction means when an element gain an electron, we say it is reduced, and when an element lose electrons, we say it is oxidized. So how to remember this? Leo the lion says girl. Leo losing electrons is oxidation and gaining electrons is reduction. Sometimes people say oil rig for this, just to remember redox reactions. Oxidation is losing and reduction is gaining electrons or losing electrons. So this is an important process actually in the industry, because this is how pure free metals are extracted from ore. For example, aluminum oxide Al2O3, which is called the bauxite, is a mineral. In this compound you can see it is aluminum oxide, so aluminum is 3+ here. To extract the pure metal, what the industry does is it let it go through the reduction process, which means when it gains 3 electrons it becomes Al, aluminum solid. This is the pure metal. So this is what it says: reduction is the process of converting a combined metal in a mineral into a free metal. So that's what an example for this. So we know the metal is generally, if it is a pure metal, it generally loses electrons, right? Zinc always makes zinc 2+, and 2 electrons are given off. But if the metal is in a compound, just like here, it will have a positive charge like 3+ here. It is a cation. When it undergoes reduction and gain electrons, it will become 0 charge. Aluminum here is the metal which has a 0 charge. That's what this part means. Oxidation is the opposite process of reduction. Now in a process, both oxidation and reduction must happen simultaneously. Reduction without oxidation is happening with another element. So oxidation is the opposite process of reduction. The element or ion must lose electrons. Oxidation means losing electrons. Losing electrons is oxidation. And loses electrons, it will have a positive charge. That's what this means. It will form a cation. We call this the cation. And if an anion undergoes oxidation, anion, chloride ion is an anion, undergoes oxidation. Oxidation is losing electrons. See what happens? Chloride ion undergoes oxidation by losing 2 electrons and forming chlorine gas, which is the elemental state, and there's no charge here, it is 0 charge. So now to understand the redox reactions, we first have to assign the oxidation numbers for every substance in a compound. Now oxidation number is something very similar to the ionic charge in a compound, ionic compound. You know, if you have sodium chloride, you know sodium has a positive charge and chloride has a negative charge. So this is how sodium chloride is formed, right? But generally assigned to nonmetals. So it's something very similar to the ionic charge in a ionic compound. But you know, let's go through the rules. Oxidation number of an atom in the elemental state is 0. So any elemental state, like for example sodium, elemental sodium is 0. Elemental chlorine is chlorine, Cl2 is 0. Like zinc is 0. So any elemental state, carbon, if you see carbon, it is 0. Elemental state is 0. So that's the first rule. The second rule is the oxidation number of a monatomic ion is equal to its charge. For example, sodium 1+ means this is the ionic charge, and we can, if you talk about oxidation state, we can take 1 plus as the oxidation state for sodium 1 plus, and magnesium 2 plus will have 2 plus. So monatomic ion equal to its charge. Number 3, the sum of oxidation numbers in the formula of a compound is 0. You know, most of the compounds are 0 charge, right? When it says sodium chloride has no charge. That's why you remember that it does not conduct electricity because ions here. We have to put it in waters to separate out into ions, right? So this is a neutral substance. So any compound is a neutral substance, a polyatomic ion. So neutral substance, the sum of oxidation numbers is equal to 0. So how do you assign the oxidation numbers? Hydrogen always has 1 plus oxidation number. Oxygen always has 2 minus. See, hydrogen in a compound is 1 plus, except there is an exception when hydrogen forms compounds called hydrides. Hydrides are when hydrogen is attached to alkali metals like sodium hydride or alkaline earth metals, calcium hydride. So then the metal gets the positive charge. So hydrogen will end up getting 1 negative charge. This is the only time hydrogen gets 1 negative charge in a hydride. Otherwise, always if you see hydrogen in a compound, you can assign 1 plus as the oxidation number for hydrogen. And oxygen always gets 2 negative charge here. Oxidation number of oxygen in most compounds is 2 negative. There's only one exception. One exception is when peroxide ion, O2 2 minus, right? Then oxidation number for oxygen will be 1 minus. This is the only time oxygen gets 1. Okay, peroxide ion. This is peroxide ion. Okay, so that is hydrogen is always 1 plus, oxygen is always 2 minus, except of course there are a couple of exceptions. Okay, and so how do you assign the oxidation number? Here H2SO4, so let me write it here so that it's clear for you. So we have H2SO4. We know hydrogen is 1 plus and oxygen is 1 minus because 2 minus, 2 minus. So what is the oxidation number for sulfur? That is what we are trying to get, and addition of this, sum of these oxidation numbers must be 0 because this is a neutral substance. So what will be X? To oxygen, from the oxygen side there are 4 oxygens. So 4 times 2, 8 negative charges from oxygen, and there are 2 hydrogens, so 2 charges from hydrogen, and so 1 sulfur must be ending up with 6 plus. Can you see that? Sulfur has to be 6 plus so that the sum of this will be 0. Okay, so sulfur is 6 plus in this case. Just in case, just assume that sulfur, there are 2 sulfurs here, then the oxidation number for sulfur will be 3 plus because 6 plus has to be divided by 2 because there are 2 atoms of sulfur. So then sulfur will be 3 plus. Okay, right. So elements in group 1, 2 and 13 have oxidation numbers equal to group number. For example, if it is lithium, it will be 1 plus. In a compound, in a formula, if you see lithium, always it is 1 plus. If you see aluminum, it is 3 plus. If you see calcium, it is 2 plus, like that. Okay, so turn the page. Now the other rule is the sum of the oxidation numbers in the formula for a polyatomic ion is equal to its charge. So for example, PO4 3 minus, when you add up the oxidation numbers, it has to be equal to 3 minus. So what will be the oxidation number for phosphorus? So let's do it here. PO4 3 minus. We don't know the oxidation number for phosphorus because that is what we are going to find out. Oxygen we know is always 2 minus. and there are 4 oxygen atoms, so 4 times 2, 8 negative charges from oxygen must equal to 3 negative. Then this has to be 5 plus, right? 5 plus. So that is how you assign the oxidation number for a polyatomic ion. And sulfate, you can see the sulfur is what we don't know. Oxygen always is a given. 2 negative charges, 4 times 2, 8 negative charge, and must equal to 2 minus because the charge is 2 minus, and then sulfur will be 6 plus. So you assign the oxidation number for in a polyatomic ion, right? Okay, now label the substance oxidized and substance reduced in the following. So what is given to us is KBr plus Cl2 giving KCl plus Br2. You can see Cl2 is the elemental state, Br2 is the elemental state, Brinkelhoff, remember. So the oxidation number for Cl2 is 0. Here it's a substance, ionic compound. So in ionic compound, charge is the oxidation number. So potassium is 1 plus and bromine is 1 minus. And then go to the other side. This is a compound. Potassium is 1 plus, chlorine is 1 minus. But here bromine is elemental state, so it is 0. So what has happened? Bromine has gone from 1 minus to 0, which means it has dropped the negative charge. So it has lost electrons, which means it is oxidation. So remember, losing electrons is oxidation, right? So this is the oxidation reaction, and we say the oxidation, the substance which is oxidized is in the reducing agent. See, it is the opposite, because taking away electrons, it helps the other substance to get reduced. So it is the agent for reduction, reducing agent. See, I have written down the reaction. We call them half reactions: oxidation half reaction and reduction half reaction. Here we have 2 Br minus giving Br2, so we can see 2 electrons are given off, and this is the oxidation half reaction, and Cl2 here is 0 and now it is 1 minus. So Cl2 is gained electrons, it has gained the negative charge, right? So we call this the reduction. Gaining electrons is reduction, right? Okay, so Cl2 is called the oxidizing agent because it is helping Br oxidized by gaining the electrons. So agent is the opposite. So label and identify the reactants above that has been oxidized. So Br minus is oxidized, Cl2 is reduced. Now when it comes to the agent, you have to think Br minus is what is oxidized, but Kbr is the reducing agent. Here Cl2 is reduced and Cl2 is the reducing oxidizing agent. Okay, right. So the agents, the oxidizing agent is the substance that oxidizes another substance by accepting electrons. The oxidizing agent is the substance that is reduced. So remember that. It's like in a singer or a dancer, in the Hollywood, they have agents, but the agent does not sing or act, right? The agent helps the singer to get gigs, right? So that is how it is. The oxidizing is, okay? Oxidizing agent is the one which is getting reduced. So is reducing agent is the one which is getting oxidized. Okay. So hope this will help.